calculus, sometimes calculation, the main formula of mathematical analysis. Main formula of mathematical analysis. Mathematical analysis. Newton, Leibniz formula. Sometimes this formula is called the main formula of mathematics, general mathematics. Why? The reason is simple. There are many applications of this formula in various directions of scientific research. And therefore, sometimes is called as main formula of mathematics. This formula was discovered by brilliant scientists, physicist and mathematician, Newton, great British scientist, and German mathematician Leibniz. The main formula of mathematical analysis has a integral from a to b, f of x dx is equals to the meaning of integral function at p minus the meaning at integral function f a. What is means this function? The main properties of this function, his first derivative is equals to underground function f of x. If you know the derivative of function, it is possible to find the integral function. It is a reverse operation with respect to derivative of function. Some words about geometrical meaning of this formula. Geometrical meaning of Newton-Leibniz formula. Meaning of S. S is area. S is area of figure bounded by the lines. Y is equals to 0. We have function y as a function of x, and what is s? This point A, the second point B, and this area S. This area S is equals to y is equals to f of x. What does it mean? S is the area of the trapezoid curve line trapezoid. It is called bounded by the line. X is equals to I. This line. X is equals to P. This line. Y is equals to 0. This line. And Y is equals to f of x. In the case, if it is necessary to find the area between two curves, for example, these curves, the first curve is the another, the g of x f of x, y. So this is to find this area. A, B. Here is area. S is equals to integral from A to B f minus g dx. It is a very important formula. There are many applications of this formula. Let's consider the simple examples. For application of this main formula of mathematics. Some information about the discovery of this formula. This formula was discovered at first by a Great Britain physicist, mathematician, Newton, and independently, maybe 10 years ago, plus x to the second power dx. No problem. Integral function here, x to the second power divided by 2 plus x to the power 4, 3 divided by 3 between 0 1. Why? The derivative of x to the second power is equals to x. X to the second power, according to our rules about delimitation, is equals to 2x divided by 2 is equals to x. We give this function about this, the second function. X to the power 3 divided by 3 derivative is equals to 3x to the power 3 minus 1. 2 divided by 3 x to the second power. We give this function. It is enough to calculate the value of this expression at 1 minus at 0. At 0 we have 0. 1 divided by 2, 1 to the second power, plus 1 divided by 3. 5 divided by 6. Correct answer. Correct answer. If there are many problems in test examination where it is necessary to calculate the meaning of defined integral, this integral is called defined integral, and to find the correct answer. 5 divided by 6. Let's consider application of this formula, Newton-Leibniz formula, for calculation of areas. There are many such types problems of school level. In school of Russian Federation there are many such problems. For example, problems, it is necessary to find the area bounded the lines y is equals to x 1 minus x, x minus x to the second power, y is equals to 0. It is necessary to understand what kind of the curve line in this case. It is parabolic function with branch down. The intersection of this parabolic function 0 and 1. 0 and 1. This parabolic function y is equals to x minus x to the second power. And y is equals to 0. It is necessary to calculate this area, this point 1. This area is equals to integral from 0 to 1 x minus x to the second power dx. Integral functions. In Russian первообразные. X to the second power divided by 2 minus x to the second to the power 3 divided by 3. Between 0, 1. Y x to the second power derivative 2x, x third derivative 3x, and we give these underground functions. At 0 we have at 0 1 divided by 2 minus 1 divided by 3. 1 divided by 6. Correct answer. This area is equals to 1 divided by 6. More interesting problems. It is necessary to find the area of curve, trapezoid curve figure, which bounded by the functions y is equals to x, y is equals to x to the power 3. This is typical problem from test examination. At first it is necessary to write the graph of function, the graph of line function y is equals to x. Y is equals to x. This function x to the power 3. Okay, these points 1 and these points minus 1. Minus 1. Minus 1. It is necessary to find the area between the function y is equals to x, y is equals to x to the power 3. About the points of intersection. If we solve the equations x is equals to x to the power 3, we give three roots. First roots 0, second roots 1, and third roots minus 1. Minus 1 to 3, minus 1. The point minus 1, the intersection between 0 and 1. It is interesting to note that according to the main theory of algebra is called about the solution of such type expressions x to the power n plus a1 x to the power n minus 1 plus x is equals to 0. General equation of such types, there are n roots. In general, complex roots of real roots. This fact is called main theorem of algebra was proved by German mathematician Gauss. Geometry. In this case, we have the equations of power 3. We have 3 real roots: 0, 1, minus 1. And about the solution of our questions. This problem concerned with this, the upper function x in the interval 0, 1, x, here x is greater than x to the power 3. Why? For example, x is equals to 1 divided by 2, these points. 1 divided by 2 is greater than 1 divided by 2 is the power 3. It means 1 divided by 8. Therefore, this we have the such function x and this function x to the power 3. If x belongs to 1 plus infinity, naturally x to the power 3 is greater than x. And in order to solve this question, it is nice to calculate s is equals to 2. We have two area, integral from 0 to 1, x minus x minus x to the power 3 dx is equals to x to the power 2 divided by 2 minus x to the power 4 divided by 4 between 0, 1. Why? Derivative of x squared, 2x. Derivative of x to the power 4, 4. X to the power 4 minus 1. We have these functions. At 0 we have 0. At 1, 2. 1 divided by 2 minus 1 divided by 4. 1 divided by 2 minus 1 divided by 4 is 1/4. Multiplied by 2, 1 divided by 2. It is correct answer. For example, if necessary to calculate the integral of such times, there are, as a rule, 4 types of answer. Only one answer is correct. Correct answer 1 divided by 2. Might be in other problems. In order to calculate the integrals, it is necessary to know the derivatives of simple functions. Simple functions, the functions, elementary functions of elementary functions. It is necessary to know the such information about the derivative, about the integral. For example, derivative of sine of x, derivative is equals to cosine of x. Cosine of x, derivative cosine of x is equals to minus sine of x. And what does it mean? It means that integral from sine, from cosine of x dx is equals to sine of x plus constant. Why? According to main properties of integral function, his derivative is equals to underground function. Derivative of sine of x is cosine of x. Derivative of constant is 0. is very important derivative of constant 0. About the integral, for example, from this formula, sine of x dx is equals to minus cosine of x plus constant y. Derivative of cosine x is equals to minus sine of x, and derivative of constant is 0. About explanation function, this is very interesting, without changing. Explanation function. Well, what this means? It means the integral from integral from explanation function dx is equals to, without changing, plus constant. Well, what this means? It means, for example, integral from 1 to 2 explanation x dx is equals to explanation, another form explanation of 2 minus explanation of 1. About another base, for example, a to the power x derivative is equals to a to the power x logarithmic function of a. What is meant? It means 2 to the power x derivative is equals to 2 to the power x natural logarithmic function of 2. Why it is possible to, for example, calculate the explanation? What is the integral from a to the a positive number, a to the power x is equals to dx. It is interesting to note that the denotion integral, the sign of integral, dx, etc., belong to Leibniz. Leibniz is namely Leibniz was the author of the first book devoted to integral calculation. The first book devoted to integral calculation was written by Leibniz, German mathematician, and the denotion dx, the sign of integral, belong to Leibniz. The denotion of Newton is very not interesting. And in mathematical sciences, this denotion is typical. Denotion of Newton is not convenient, maybe. Is equals to a to the power x logarithm function of a plus constant y. Derivative of x equals a to the power x multiple logarithmic functions, and we have a to the power x logarithm function, a divided by logarithm function. Then we have such results. Simple equations. No equations. Example. Simple. For example, integral. Or for example, from 0 to 1, 3 to the power x dx. According to this formula, we have 3 to the power x divided by logarithmic function 3 between 0 1 is equals to 3 to the power 1 divided by logarithmic function 3 minus 3 to the power 0, it means 1, minus 1 divided by logarithmic function of 3 is equals to 2 divided by logarithmic function of 3. This is correct answer. About another type logarithmic function, this is very useful to know. Logarithmic functions. Logarithmic functions. If we calculate the logarithmic functions with natural base, we give 1 divided by x. If we have the another base, for example, logarithmic function with respect to a. Logarithm with respect to a is positive number. A is more than of x is equals to 1x logarithmic function of a. Why? It is possible to give this formula because there are good formula for changing of base. School problem, chapter logarithmic function. What this means? Logarithm with respect to ax is equals to natural logarithm of x divided by natural logarithm of a. If it is necessary to calculate logarithm function at x, first derivative, the logarithm function 1 divided by x, 1 divided by logarithmic function of a. We give these results. Oh, it's simple, maybe simple. Example, simple example. For example, logarithmic function of x dx. X logarithm x minus x plus constant. It is a very useful formula. Why? If we calculate the derivative of this function x logarithm x minus x plus constant, derivative of function, it is not in order to calculate the derivative of this function, it is production of two functions. The derivative of first function, logarithm function, plus x, logarithm function x, derivative, minus derivative x plus 0, derivative of constant 0. 1 logarithm x plus 1 minus 1 derivative of logarithmic function 1 divided by x, we give this function. Or maybe simple example, integral from 1 to 2 logarithmic function dx x logarithm x minus x between 2, no, 0, 0, between 1 and 2. 2 logarithm 2 minus 2 minus the meaning of this function at point 1. 1 logarithm of 1, 0, 0, minus 0, plus 0. And correct answer 2 logarithm function 2 minus 1. This is correct answer for. About another application of integrals. There are many formula which calls very useful formula which calls is called as part integration by part. Integration by part. Integration by part. This is very usable formula. Integral u dv is equals to uv minus integral v du. There are very useful formula. For example, our example, logarithm x dx according to this formula u dv uv x logarithm x minus v du v minus x u logarithm x derivative 1 divided by x, 1 divided by x, the derivative of logarithmic function dx is equals to x logarithm function minus x or plus constant. We give this formula. It is very useful formula for calculation of derivative of function. Integration by part. Integration by part. Very useful formula. And finally, we consider the one interesting formula. From formula, it is not simple, but in order to calculate such types of integral, it is necessary to know, for example, trigonometric formula. Problem. It is necessary to calculate dx sine of x. It is not simple problem. It is not simple. In order to solve this problem, we can know there some trigonometrical formula of such types. One is equals to main formula of trigonometrics, sine to the second power x divided by 2 plus cosine to the second power x divided by 2. It is Pythagorean theorem in trigonometric. And sine of x is equals to 2 sine of x divided by 2 cosine x divided by 2. Why? There are such formula, sine of 2 alpha, 2 sine of alpha, cosine of alpha. If alpha is equals to x, we give this formula. And we can write the following formula. Sine of the second one, x divided by 2 plus cosine 1. Cosine x divided by 2 divided by 2 sine of x divided by 2 cosine x divided by 2 dx is equals to, after the division, 1 divided by 2 sine to the second power divided by sine the first power, we give sine x divided by 2 divided by cosine x divided by 2 integral dx plus 1 divided by 2 integral cosine at cosine to the second power divided by cosine is the first power, cosine x divided by 2 divided by sine x divided by 2 dx. It is an interesting example. Why? About this, it is possible to calculate this integral. It means integral differential sine cosine x divided by 2 divided by cosine x divided by 2 with sine minus plus integral without 1 divided by 2 plus integral d sine x divided by 2 divided by cosine divided by cosine x divided by 2. Why? What is the differential of function? The differential of function, first derivative of function dx. What is means differential of cosine of derivative of cosine of x divided by 2 is equals to minus sine divided by 2. Multiplied by this, it is complex function, derivative d cosine x divided by 2 is equals to minus sine x divided by 2, because derivative of cosine is equal to minus. The derivative of x divided by 2, 1 divided by 2, then we give such equations. And finally, as you know, the properties of logarithmic function. Integral dy divided by y. Logarithmic function plus constant. We have the logarithmic functions is equals to minus logarithmic functions cosine x divided by 2 minus logarithmic function or plus logarithmic function sine x divided by 2. Very interesting interval, sine divided by x divided by 2. And the properties of logarithmic functions, logarithm a minus logarithm b, as you know, logarithm a divided by b. If you use these properties, we have is equals to logarithm sine x divided by 2 divided by cosine x divided by 2. That is all logarithm plus constant, and finally integral dx sine x is equals to, it is tangents of function sine divided by cosine, logarithm tangents x divided by 2 plus constant. Because logarithm function is defined only for positive, it is possible to give such absolute value. That is all. It is application of part integration, the trigonometrical function for calculation of integral. Calculation of integral is very interesting directions of mathematical analysis. There are table of integrals, table of ordinary integrals, where we can give the many integrals, not simple. For example, such types integrals, the upper divide, translation the was written by scientists, I suppose, maybe German scientist White. Table of integrals. It's very interesting. A book, textbook, table of integrals. About another application of integrals. Integrals are used for calculation of surface, the figure of rotation, for calculation of volumes, three-dimensional volumes. For example, it is possible to calculate the area of sphere, total area. For example, as you know, 4 pi r to the second power. The volume of the sphere, as you know, 4 divided 3 pi r to the power 3, etc. There are many applications of integral calculation for solution very interesting problems. For example, the total surface of sphere, the volume, etc. I suppose that we consider another application of integral calculus in the next lecture. Thank you very much for your attention.